So today we're heading to Brookvale in the northern beaches of Sydney to visit MJ Labs, which is run by a dental technician named Jonas, who's been an Asiga user for the last few years. He's been printing for the last 6 months with the ultra gloss lift trays to produce splints for his business. Hey Jonas.
Hi Justin.
Good to see you, mate.
Good to see you too. Come in.
All right. So this is your 3D printing setup?
That's my 3D printing setup.
Right. You've been running these for how long now?
The first Macs I bought, I believe, end of 2019, and I got 2 more 2 years ago, maybe.
I remember we had a phone call maybe late last year or early this year about some issues with you printing splints, and I introduced you to the fact that we had a tray that might help you, the lift tray with the ultra gloss film. You know, you started trying that, and then you've had some experiences with that. So, yeah. What's been going on?
We are printing splints since we bought the first Macs, and we used to use a standard tray. So you were working on some tray that can reduce polishing time, and I was looking for ways to reduce polishing time, and you came up with the ultra gloss that we loved. So I'm not really sure what you have done to the tray, but it totally changed the game. We have 0 issues since we tried it. It's been now probably close to half a year when we have it. We printed, I don't even know how many splints in this tray, but 100% success rate. Doesn't even matter how we position it. As soon as there's no islands coming up, it just does the job. I even was trying to push it to the limits for how small the actual space or the spot should be touching the build platform, so it would fail. Even though it's 5 mils, it still print the splint. So that kind of saves time in the lab, because it really doesn't matter whom is going to be creating the print file. It's just going to print it. And of course we could have the ability to come back to the soft bluish, because it just prints it so nice. The fit is perfect, and no more issues with the splint whatsoever. No more lines. It's very shiny, very glossy, no more bubbles, and it surely does save our time. Instead of like solving problems, we can just spend more time in designing more splints and producing more splints to the customers.
Yeah, I mean, that's a great outcome, because I remember, I called you last week just to check on how you were going with the lift trays, and you said that you've been getting good results, but I also was aware that you might not have explained exactly how it's working or why it's actually giving that result. So the lift trays are, I think, really a fascinating improvement in some applications of 3D printing. So, I mean, it still has all the features. This is an ultra gloss lift tray. So it still has the diffusing film, but the Teflon film in this is a different type of fluoropolymer. And it has the characteristic that it maintains a liquid interface between the film and the cured layer. This is a novel material that the film's made from, it's genuinely a very expensive material. It's really the magic that allows this liquid interface to be maintained between the film and the part. The normal Teflon film, the layer cures all the way to the film, but the lift film, it maintains a liquid barrier. And that liquid barrier, it allows the separation between the cured layer and the film to happen with less force, because it's actually not contacting. So it gives a much better result for the cured layer, especially when it's like a tough, flexible material, which often splints are. They're sort of tough materials, but they're a little bit more rubbery when they're in the green state. The layer with the overhangs tends to deform less when separating, because it's actually not contacting. And it also tugs less on the film, so the film receives less wear and tear as a result of that. So that's kind of how it works. But But the knock-on effect is that you also, because you're naturally not adhered to the film, when you separate, you don't have to overcome that adhesion, and you can actually separate less. So you can, instead of using a default separation of say 10 millimeters like the Max typically uses, you can go down to 1 or 2 millimeters. So
cut the printing time.
You'll cut the printing time. So that's, maybe you can realize some more of the benefits of the lift tray.
Yeah, that makes sense. Definitely gonna give it a go.
Yeah, so try it out. But and so you've been running off this lift tray for 6 months and it hasn't.
Yeah, we probably finished, I would say, already 4 bottles on the same lift tray. It still looks as new. It's still printed the perfect splints.
What about the surface finish?
I would say it's probably equal or even better to the normal ultra gloss. It's incomparably better than the standard ones. You just don't really see the layers. It's just super glossy, super shiny.
So that might be again the fact that the layers that are formed are not adhered. They're floating on the liquid interface.
Yeah.
And just for those, I mean, you're printing at what, 50 or 100 microns for
50.
this? 50 microns. So when you have like an overhanging layer that's only 50 microns thick, that's half the thickness of a sheet of paper.
Yeah.
When you're pulling away, it's not experiencing as much mechanical force.
Yeah.
And so you get less ripple in that. And like a lot of other users have also commented that the surface finish of the part is a lot smoother. And with the ultra gloss effect that you're after, you really do want that smoothness because you don't want to have to polish it afterwards. So
it surely did cut the time of polishing. And now once you told me what it is, it kind of makes sense, because once I saw it the first time, I thought it's an ultra gloss with more capacity, but apparently it's a total different technology. It does work.
Yeah, it works, but it's
work.
I think it's also knowing when to use it. It has a diminishing effect if the material that you're printing is, for example, stiffer. Like if you cure a layer and it's already forming a stiff, it's mechanically stiff in the green state, it doesn't tend to experience so much issues with the separation forces during the layer process. So you tend to, it's not really a must-do in all cases, but certainly for splints, it makes a big difference. You also can use it for, we don't only make it in an ultra gloss version, but we have like a plain film version.
Yeah.
So again, with some materials like models, you'll definitely notice an improvement in speed or also surgical guides.
And as you said, like the normal lift is going to be okay for the models, or basically denture bases as well?
Yeah, denture bases. I mean, anything still works with the lift. I think in choosing where to apply it, depends on the application where you get the best return. I think clearly in splints, there's a large benefit because you have a really complex geometry. You don't want to physically polish it. If you can avoid that, you're saving a lot of manual time. Whereas, maybe there are some other more generic parts that you don't really see so much benefit on. But certainly for denture bases, you might get a lift from that. Surgical guides. Yeah, I guess the other good application is where you tend to observe that printing a particular material is really working the tray film hard, that you're seeing, for example, slight puckering after a few prints. So any material or any application where you have that occurring. For example, in the audiology industry, they're printing these conical shapes for a hearing aid, and those shapes tend to have a widening, so they have like an overhang, and that tends to create what we call this suction cup geometry, where the very edges of the part are overhanging and they're quite thin and they're flexing, and they can actually cause that additional pulling on the layer that can cause that damage to the film.
Yeah.
So whenever there's a geometry like that, a lift tray can give a big benefit, that you're not deforming the tray, you're not deforming the part, better surface finish. It's all on a case-by-case basis.
One of the really important things that we like here is supportless printing. Supportless printing in here, I mean, it's not that just there's zero supports on the build platform, but in the inside of the splint as well. Like the splint has the thickest part and the strongest part on the occlusion, but all the interior section is that undercut that covered the interiors. So we used to reinforce it with the supports, but with the lift tray, it's none. The good thing about it that because to remove the supports, it's a bit time consuming, but without being time consuming, you can actually see those small spots in the inside of the splint where you touched it. By not having the supports, the whole splint comes in like a monolithic, shiny, glossy piece of plastic.
You said something else that was interesting, that you don't get bubbles in the parts when using the lift tray. So
Yeah,
tell me
so
about that.
we used to get bubbles that in the splint itself, that were kind of growing in the lines of a like
On the contours of
yeah,
the
on the contour, like a straight contour through the whole splint or through some parts of the splints. With the lift, we don't have this issue anymore. The splints are clean, clear, and glossy.
Cool. Well, it's been great to see your setup here and really learn about your experiences in using the lift trays. Great to see you. And
Thanks
we'll
for
talk
coming.
again soon.
Yeah.